Hello, and welcome to planning and implementing a high availability and disaster recovery environment. If you'd like to follow along, please note that we have the URL listed here on our slide. Data must be available when the business needs it. That means that solutions hosting the data must be designed for availability and recoverability from the beginning. In this section, we will cover configuring, testing, and managing a solution for high availability and disaster recovery, or HADR, here in Azure for both infrastructure as a service, IaaS, and platform as a service, PaaS deployments. In this lesson, we will describe high availability and disaster recovery strategies. And if you'd like to follow along, please also note there's a URL specific for this section here on our slide. Implementing HADR database platform solutions is more than just deploying a feature. You must understand why and what you're doing to implement the right strategy. We will define RTO, RPO, HADR, and devise a strategy using HADR in this section. By the end of this lesson, you will have a solid foundation that will allow you to implement HADR solutions here in Azure. Suppose you work for a company that sells widgets, both in store and online. Your main application uses a high transaction database for orders. What would happen if the server or the platform hosting that transaction database had a problem that made it unavailable or inaccessible for some reason? What impact would it have on your business? If the right solution is in place, the database would come online in a reasonable time frame with not a lot of effort, thus allowing business to continue with minimal to no impact. Recovery time objective, or RTO, is the maximum allowable time to restore systems or databases after an outage, with consequences like financial loss or operational disruption if exceeded. It emphasizes that calculating RTO must consider factors such as backup file transfer and network speed, and that RTO can be defined for an entire solution or individual components like SQL Server instances. RTO is a critical metric in disaster recovery planning, helping organizations set realistic recovery goals and allocating resources effectively. Benefits include minimizing downtime, protecting revenue, and maintaining service continuity. Use cases range from ensuring rapid recovery of online banking systems to restore production databases in manufacturing environments within a defined time window, and more. Recovery Point Objective, or RPO, defines the maximum acceptable data loss for a business and the point in time in which a database must be restored following an outage. While zero data loss is ideal, it's often unattainable due to environmental factors such as system latency or backup frequency. Azure Backup and Recovery Solutions help organizations meet their RPO targets by offering an automated backup, scalable recovery options, and integration with other Azure services. A common use case is restoring an IaaS VM running SQL Server after a failure. If the RPO is 15 minutes and the outage occurs at 10 a.m., the system may be recoverable to at least 9:45 a.m. to meet business expectations. These capabilities are essential for disaster recovery planning, regulatory requirements and compliance, and protecting mission-critical applications. It is also important to note that there are many other environmental factors that may interfere with you getting your ideal RPO. So just have a plan for that. Build that in. To bring your data back, you need a plan A, and if that fails, you need a plan B, and if that fails, a plan C, a plan D, etc. It's important to start with the basics, a backup of the information that you cannot lose, and the system that is it is on and the network that it uses, all those components that make it up, we need to make certain we have high availability for. Think about what could go wrong and what is your plan or plans to bring it back. Some plans may be slower to implement than others, and you may want a mix of plans to bring your data back, but you need to have at least one, if not more, plans on how you're going to bring your data back. To define recovery time objective and recovery point objective, it is important to formally document and periodically review RTO and RPO for both individual components like SQL Server and then also the overall application architecture. RTO defines the maximum time allowed to restore systems after an outage, while RPO sets the acceptable threshold for data loss. These metrics are critical in designing high availability or HA and disaster recovery or DR strategies as they guide the selection of the technologies and the procedures. For example, if SQL Server can recover in 5 minutes, but application servers take 20, the overall RTO is 20 minutes, even though SQL Server meets its target. Similarly, if transaction log backups occur every 30 minutes, but the RPO is 15 minutes, the recovery point may fall short unless backup frequency is adjusted. Benefits of defining RTO and RPO include reduced downtime, minimizing data loss, and improved business continuity. Use cases range from financial systems requiring near zero data loss to healthcare applications needing rapid recovery to maintain patient care. By aligning recovery capabilities across all components and documenting them clearly, organizations can ensure resilience and compliance with service level expectations being met. Let's compare IaaS and PaaS solutions in Azure, focusing on availability and disaster recovery strategies. When it comes to availability, the choice of IaaS or PaaS makes a difference. In IaaS, users manage virtual machines and must configure availability manually using features like availability zones, availability sets, and database-level solutions such as availability groups or log shipping. These setups offer flexibility but require careful planning to avoid downtime from hardware failures or even patching. PaaS solutions like Azure SQL Database simplify this by offering built-in high availability and minimal configuration for disaster recovery, making them ideal for organizations seeking streamlined operations. Both models support optional replication to other regions for disaster recovery. Benefits include reduced downtime, enhanced reliability, and simplified maintenance. Use cases here range from really mission-critical applications requiring high uptime to environments where automated failover and minimal intervention are preferred for business continuity. Best practices recommended here are aligning your solution choice with control needs. So use IaaS for granular configuration and PaaS for ease of use and built-in resilience. SQL Server HADR features for Azure Virtual Machines focuses on 2 primary high availability and disaster recovery options for SQL Server in Azure VMs. We have the failover cluster instance, or FCI, and we have the availability groups, or AGs. And what you'll notice here is the FCI provides instance-level protection, meaning the entire SQL Server installation, including logins, jobs, and databases, is covered during failover. FCI relies on a shared storage model and requires an underlying cluster mechanism like Windows Server Failover Cluster, or WSFC for Windows, or Pacemaker for Linux. AGs, on the other hand, offer database-level protection, replicating user databases across nodes without shared storage. However, system-level objects like SQL Server agent jobs and linked servers must be manually synchronized. Both FCIs and AGs require a cluster foundation and should be chosen based on recovery needs. Benefits of the FCIs include unified failover for all instance components, and it's ideal for environments needing centralized management. AGs offer flexibility, enabling granular failover and read scale capabilities suitable for distributed apps or performance optimization. Use cases include for FCIs, mission-critical systems requiring full instance recovery, and for AGs, it's used for applications needing high availability across regions with minimal data loss. Now, you may also consider using log shipping. It is very simple, it is reliable for a disaster recovery solution, and it automates the backup, copy, and restore process of the transaction logs to a secondary server, providing a warm standby environment. Now, it's been available in SQL Server for almost 30 years. So you may be asking yourself, why is it available here? Let me ask you, what is your oldest SQL Server version that you are running? And yes, that's why we have it here, because some of us are running really old systems. And so this works with very old SQL Server systems and could be helpful to bring these back in the event of a disaster. So some of its use cases include environments where automatic failover is not required, but maintaining a secondary readable copy of the database for reporting or manual failover is very beneficial. So we're going to focus on all of these as we go forward. So we're going to first talk about here SQL Server's failover cluster instance. And this offers an instance-level high availability by enabling the entire SQL Server instance, including logins, jobs, and LinkedIn servers, to fail over to another node in the event that there is a problem. This failover process involves a full stop and restart of our SQL Server, ensuring all instance-level objects remain intact and operational without additional configuration. FCIs require an underlying cluster, as we mentioned before, like our Windows Server failover cluster or pacemaker. It also requires shared disk storage. You could use something like an Azure file share or an Azure shared disk or more. And it also requires an Azure load balancer. It also depends on the Active Directory Domain Service, or ADDS, and DNS for proper operation. FCIs are ideal for mission-critical workloads where minimizing downtime and maintaining full instance continuity is essential. They support up to 2 nodes in SQL Server Standard Edition and are commonly used in traditional on-prem environments. And now it's been extended out to Azure. Best practices include provisioning spare capacity on nodes and ensuring shared storage is resilient and accessible across failover scenarios. Always-on Availability Group, or AGs, protect database-level protection here by replicating databases across a primary and 1 or more secondary replicas. In Standard Edition, an AG supports 1 database and 2 replicas. 1 is the primary and 1 is the secondary. While Enterprise Edition allows multiple databases and up to 9 replicas, where you have 1 primary and 8 secondaries. So the primary replica handles all the read-write operations, while the secondary replica are loading in a loading state, and it can be used for read-only queries, backups, or even DBCC checks and commands that you can run behind the scenes for it. These features are exclusive to the Enterprise Edition. Synchronization between replicas can be synchronous for minimal data loss or asynchronous for lower latency. The AG listener has a virtual network name and an IP address, enabling seamless client connectivity during failovers. AGs require an underlying cluster and offer a read scale option for offloading read workloads without failover support. Benefits include high availability, disaster recovery, and performance optimization. Use cases include mission-critical systems like online banking or healthcare applications that demand continuous availability with minimal data loss across regions. The architecture and benefits of always-on availability groups offers database-level protection in both IaaS and PaaS environments. The setup includes a primary replica for read-write operations and a secondary replica for read-only access, with replication configured as synchronous or asynchronous to ensure data consistency and availability. While AGs protect individual databases, they require manual recreation of the instance-level objects, such as the SQL Server agent jobs, logins, linked servers, on the new primary during failover. So make sure to use Microsoft Entra ID authentication with all of its security features like MFA and more for an extra layer of security. In contrast, SQL Server failover cluster instances protect the entire SQL Server instance, automatically preserving all instance-level objects during failover. FCIs require shared storage and an internal load balancer, and they're ideal for traditionally high availability deployments where minimal manual intervention is preferred. Use cases here include mission-critical apps requiring full instance continuity and environments where centralized management of SQL Server components is essential. Best practices recommended here are using Azure Premium File Shares. You could use iSCSI. You could also use an Azure Shared Disk for shared storage. And you need to implement Active Directory Domain Service and DNS within Azure to support the FCI functionality. This slide illustrates how zone-redundant Azure SQL databases use a multi-zone architecture to deliver high availability and disaster recovery. The underlying database files here, MDF and LDF, are stored on SSDs for low latency and high IOs, and data is replicated across up to 3 secondary replicas in different availability zones. The primary replica handles the read-write operations, while the secondary replicas receive transaction updates either synchronously or asynchronously. Azure Service Fabric manages failover, ensuring that if the primary fails, a fully synchronized secondary takes over, and a new replica is created to maintain quorum. The AG listener ensures seamless client redirection to the new primary. While the setup enhances resilience, it may introduce latency due to cross-zone communication, potentially impacting your OLTP workloads. However, switching between zone redundant and single zone configuration is an online operation. Benefits here include automatic failover, minimal data loss, and high availability across data centers. Use cases here include mission-critical apps for financial systems or for healthcare that require continuous uptime, and even data integrity here is offered during our regional disruptions. Log shipping is a long-standing SQL Server feature, as we talked about a little earlier, that provides database-level protection through a simple backup, copy, and restore process. It automates the transfer of transaction log backups from a primary to a secondary server, creating a warm standby that can be activated in case of failure. While log shipping does not replicate instance-level components like SQL Server agent jobs or linked servers, it remains one of the most straightforward and cost-effective methods for achieving high availability and disaster recovery, or HADR. Common use cases include disaster recovery planning and enhancing local availability, especially in environments where simplicity and reliability are key. Benefits include protection against human error, such as accidental data deletion, minimal configuration overhead, and flexibility in deployment. Best practices with this product include recommending monitor job status regularly and securing your backup storage to ensure consistent and recovery readiness. SQL Server log shipping automates the backup, copy, and restore of transaction logs from a primary server to one or more secondary servers, maintaining a warm standby environment for disaster recovery. The process involves a backup job on the primary server, a copy job that transfers the logs to a secondary server, and a restore job that applies the logs to the secondary database, nearly synchronized. Applications must handle failover manually, often using DNS aliases to redirect traffic. Benefits here include a simple, cost-effective disaster recovery solution with minimal data loss and no need for shared storage or clustering. Use cases include environments where automatic failover isn't required, but maintaining a secondary database for reporting or manual failover is essential, such as our financial services, healthcare, and e-commerce platforms needing high availability and data protection. Azure HADR features for Azure Virtual Machines reflects 3 core high availability and disaster recovery options. We have availability sets, availability zones, and Azure Site Recovery. Availability sets distribute VMs across fault and update domains within a data center to minimize downtime during maintenance or hardware failures. Availability zones go further by placing VMs in physically separate data centers within a region, offering protection against data center level outages. Azure Site Recovery provides cross-region disaster recovery by replicating workloads to a secondary location, enabling failover during major disruptions. Benefits here include improved uptime, fault isolation, and robust disaster recovery capabilities. Use cases here include deploying mission-critical apps with high availability requirements, ensuring compliance with business continuity plans, and protecting availability sets within a data center provide 3.5 nines SLA to mitigate hardware failures. Availability zones across multiple zones in a region offer 4 nines SLA to protect against data center-wide outages. And Azure Site Recovery with region pairs for cross-region disaster recovery with industry-leading recovery point objective and recovery time objective offer an excellent option here, as we're going to explore it in a little bit more detail coming up. These options help organizations reduce downtime, protect data, and meet compliance requirements. In the context of SQL Server and Azure SQL, these availability models are critical for ensuring continuous access to the database and minimizing data loss, and also support mission-critical workloads that require high uptime and robust disaster recovery strategies. Other use cases involve hosting critical apps that have high demand in availability, also implementing robust disaster recovery plans, and ensuring data residency compliance, while minimizing operational impact from hardware or infrastructure failures. Azure enhances virtual machine uptime by distributing virtual machines across multiple fault domains, or FDs, and update domains, or UDs, within a single data center. Fault domains protect against hardware failures by ensuring VMs don't share the same physical infrastructure, while update domains stagger the reboots during maintenance to avoid simultaneous downtime. This configuration acts like an anti-affinity rule, ensuring that VMs such as SQL Server log shipping pair are never placed on the same physical server, while availability sets protects against infrastructure level failures. They do not safeguard against issues within the VM's OS or SQL Server itself. Benefits here include improved resilience to hardware and maintenance-related outages, and use cases include deploying high-availability SQL Server configurations and application tiers that must remain operational during planned and unplanned infrastructure events. Azure Availability Zones, which distribute virtual machines and other resources across physically separate data centers within the same region to ensure high availability and resilience against data center level failures. While this setup enhances infrastructure durability, it does not protect against failures within the guest operating system. Availability zones build on the foundation of the availability sets and offer low latency connections, typically under 1 millisecond, making them very suitable for synchronous replication scenarios such as SQL Server availability groups. In SQL environments, this architecture supports critical workloads like business analytics, CRM systems, and e-commerce platforms by ensuring minimal downtime and robust disaster recovery. Azure SQL Database can also be deployed across availability zones, allowing the organization to maintain high availability with built-in HADR features and meet performance targets through zone-aware deployments. Best practices include testing latency between the zones and understanding that zone numbers are logical representations, meaning deployments in the same zone number across subscriptions may reside in different physical data centers. Azure Site Recovery, or ASR, provides a flexible VM-level disaster recovery solution that is agnostic to SQL Server, meaning it replicates disk-level changes without awareness of the database transactions or RPO requirements that you might have. ASR supports hybrid disaster recovery, enabling replication from on-prem environments to Azure, and it's often used to migrate workloads to the cloud. It allows non-disruptive testing of disaster recovery plans, ensuring readiness without impacting production. However, because ASR operates at the disk level, it may not guarantee transaction consistency for recovering of a SQL Server workload. ASR benefits include simplified disaster recovery setup, seamless migration capabilities, and safe testing for failover scenarios. Use cases include data center migrations, disaster recovery for non-database specific workloads, and maintaining business continuity for applications where transaction level recovery is not critical. Azure Site Recovery provides a platform-level disaster recovery solution that complements SQL Server deployments by lowering the RPO and RTO. While ASR is not SQL specific, it can replicate entire virtual machines hosting SQL Server, making it a valuable tool for ensuring business continuity. A common SQL-related disaster recovery example using ASR would be replicating a production SQL Server VM from one Azure region to another. In the event of a regional outage, ASR enables failover to the secondary region, restoring that SQL Server instance with minimal data loss and downtime. This setup is ideal for enterprise applications, financial systems, and e-commerce platforms that rely on SQL Server for secure, high-performance data management and require robust recovery strategies. This makes it a versatile option for business continuity across various workloads. Azure Site Recovery enables seamless disaster recovery by replicating that virtual machine across regions, including Azure VMs, on-premise VMware, and Hyper-V VMs, physical servers, Azure Stack VMs, and even AWS Windows instances. The diagram shows a high availability setup in Region 1 with VMs grouped into availability sets and connected via an internal load balancer. In the event of failure, Traffic Manager will redirect workloads to Region 2, where replicated disks and VM configurations ensure continuity. As a fully integrated Azure service, ASR is automatically updated with new features. It supports sequencing of multi-tier applications. It allows non-disruptive testing of disaster recovery plans and more. SQL benefits include simplified disaster recovery for SQL Server workloads without requiring SQL-specific configurations or continuous disk-level replication and automatic failure to maintain availability. SQL use cases include protecting mission-critical databases, maintaining uptime and data integrity during a regional outage, and even maintenance can come essential with this. Azure Site Recovery process enables disaster recovery here by continuously replicating virtual machine data from the source environment, let's say East US, to the target environment, Central US. The process includes VM registration, caching replicated data locally, transferring it to the target storage account, and then initiating failover to restore operations in the target region. It ensures business continuity with automatic recovery from on-premises to Azure or between Azure regions also. For SQL Server workloads, ASR provides a robust protection for transactional systems, data warehousing, and business intelligence apps by minimizing downtime and data loss. Hybrid solutions are very common as organizations integrate on-prem infrastructure with Azure to create flexible, resilient architectures that support backup, migration, and disaster recovery across environments. Here, networking is the most critical component, and it's recommended to use ExpressRoute for high-speed private connections and site-to-site VPN for secure connectivity. Hybrid solutions are typically IaaS-based, as PaaS offerings like Azure SQL Database are not really designed for traditional hybrid configurations, though exceptions like SQL Server transactional replication from on-prem into our Azure SQL managed instance do exist. SQL benefits include off-site backups to Azure for enhanced data protection, seamless migration paths, and the ability to extend high availability and disaster recovery capabilities to the cloud. SQL use cases here include backing up SQL Server Database to an Azure Blob Storage, migrating workloads to Azure for scalability, or adding a secondary AG replica in Azure to support business continuity while maintaining on-premise operations. High availability architecture using always-on availability group within a single Azure region is designed to protect SQL Server data by maintaining multiple synchronized copies across virtual machines. It eliminates the need for shared storage like failover cluster instances or FCIs. which simplifies deployment and reduces its complexity. The setup includes domain controllers and SQL Server nodes distributed across availability sets and subnets with an internal load balancer facilitating the communication. This architecture supports automatic failover. It meets recovery time objectives and recovery point objective targets with very minimal to no data loss, and it enhances availability during patching scenarios. SQL Server benefits here include high performance for complex queries, secure and scalable data management, and of course, the support for ACID-compliant transactions. Use cases include enterprise applications, financial systems, CRM platforms, data warehousing, and more, all requiring continuous availability and resilience against infrastructure failures. The standardized access to both primary and secondary replicas also supports read-only workloads and improves overall system efficiency. See our example here with high availability architecture using SQL Server failover cluster instance within an Azure region, a single Azure region. There are 2 Azure VMs with attached data disks connected via Storage Spaces Direct and managed by a Windows Server failover cluster, all within an availability set to ensure redundancy. An Azure load balancer directs traffic to the active node. This architecture is a well-known and proven solution that meets most RTO and RPO requirements. It also provides a standardized method for application connectivity, and it enhances availability during patching scenarios while allowing seamless failover. It is designed to protect against network card failure and disk failure. SQL benefits include full instance-level protection, minimal downtime, and compatibility with existing Windows-based SQL Server deployments. SQL use cases include high availability configurations for critical workloads that require continuous access and resilience against hardware or maintenance-related disruptions. Here we see a comparison between SQL Server high availability architectures, the failover cluster instance, and the availability groups, highlighting the differences in protection scope, storage configuration, and failover behavior, along with the secondary replica accessibility. FCIs protect the entire SQL Server instance using shared storage and do not support readable secondaries, while the AGs protect individual databases using non-shared storage and allow readable secondary replicas, making them ideal for scaling read workloads. Both architectures rely on Windows Server failover clustering, but differ in failover policy settings and the resources covered during failover. SQL Server benefits include efficient data management, high performance for very complex queries, and robust security and scalability. Use cases for FCI include legacy systems requiring instant-level protection and centralized management, while AGs are suited for modern applications needing database-level high availability, readable replicas for reporting, and minimal downtime during patching or maintenance. Here is a DR example using a multi-region hybrid availability group with disaster recovery architecture using SQL Server always-on availability groups deployed across multiple Azure regions or in a hybrid setup with an on-premises infrastructure. All replicas participate in the same Windows Server failover cluster, requiring consistent Active Directory and DNS configurations across environments. This architecture assumes strong network connectivity and recommends using a cloud witness to maintain quorum. SQL benefits include high availability and disaster recovery with minimal downtime, geographical redundancy, and synchronized replicas that protect against regional failures. SQL use cases here include mission-critical systems like banking, healthcare, or a global e-commerce platform that requires continuous availability with very fast recovery times across regions, or even between on-prem and the cloud environments it can be used. An Enterprise Edition feature of SQL Server known as Distributed Availability Groups was first introduced in SQL Server 2016. Unlike traditional AGs that operate within a single Windows Server failover cluster, distributed AGs span multiple availability groups across different clusters. In this architecture, the global primary hosts the read-write database, while the primary of the second AG, called the forwarder, synchronizes its secondary replicas. This setup enhances flexibility and resilience, especially in hybrid and cloud environments like Azure, by simplifying quorum management and enabling cross-cluster replication. Use cases include business intelligence, data warehousing, real-time analytics, and high availability solutions, all of which are strengthened by enterprise-grade features like distributed AGs that ensure continuous data availability and disaster recovery across geographically dispersed systems. Now it's time for our knowledge check. Question 1. What is RPO? Answer: the point to which data needs to be recovered after a failure. Question 2. What is a hybrid solution? Answer: a solution that has resources both in Azure as well as on-premises or in another cloud provider. Question 3. What is available after failover with database level protection and SQL Server? Answer: whatever is in the database, anything outside must be dealt with manually. Welcome to our section on exploring IaaS and PaaS solutions for high availability and disaster recovery. If you'd like to follow along, please use the URL that we have here on the slide. If you're using IaaS for deploying your database solution, there are considerations for properly deploying HADR. Suppose you want to use an availability group. How is deploying Windows Server failover cluster different? Are there any specific considerations for AGs or availability groups that differ from our on-premise solution? We will take a look at some of these questions and more in this section, where we will talk about what to consider when deploying our WSFC and AGs here in Azure, as well as taking a closer look at active geo-replication and auto failover groups. Windows Server Failover Cluster, or WSFC, is essential for enabling high availability in SQL Server deployments using availability groups or failover cluster instances. WSFC protects against server-level failures, such as network outages or relational database management system crashes, ensuring that SQL workloads remain available. It is designed for availability, not for performance scaling, and it can be managed via the Failover Cluster Manager or even PowerShell. In Azure, deploying WSFC follows similar principles as on-prem setups, but with Azure-specific considerations like choosing a witness resource. The witness resource can be a disk, a file share, SMB 2.0 or later, or it can even be a cloud witness. It is recommended that you use that Cloud Witness as it's fully Azure-based, especially for multi-region or hybrid deployments, as it leverages Azure Blob Storage to maintain quorum and prevent that split brain scenario. The Cloud Witness feature is available for Windows Server 2016 and later. SQL Server benefits from this architecture through enhanced reliability, secure and scalable data management, and support for complex queries. Use cases include business-critical apps such as transaction processing, data warehousing, and analytics platforms that demand continuous uptime and resilient infrastructure. Here are some essential configuration requirements for setting up a Windows Server failover cluster in Azure, which is foundational for our SQL Server high availability solutions like always-on availability groups and the failover cluster instance itself. It is recommended that you use a Cloud Witness, which is supported in Windows Server 2016 and later, to maintain quorum across regions or in a hybrid environment. Each Windows Server failover cluster must have a unique name, distinct from any other FCI listener, and also have a server, and it requires one IP address per subnet. The WSFC name must be registered in DNS, and it needs to be associated with the cluster name object, the CNO, in Active Directory domain service. While each node typically uses a single virtual NIC, DHCP warnings during cluster validation can be safely ignored. If Microsoft Distributed Transaction Coordinator is needed, it must be clustered with a shared disk, even in AG scenarios. SQL benefits include robust failover support, seamless integration with Azure infrastructure, and improved resilience for critical workloads. SQL use cases here include deploying highly available SQL Server environments that demand continuous uptime and fault tolerance across regions and even in hybrid setups. Here we see a structured 5-step process for setting up a failover cluster, which is essential for ensuring high availability in SQL Server environments. These steps include verifying prerequisites, installing the failover cluster feature on all intended nodes, validating the configuration using the cluster validation wizard, creating the cluster with the Create Cluster Wizard, and finally, setting up cluster roles to manage the workloads. This process is foundational for implementing availability groups in SQL Server, particularly in the Enterprise Edition, which supports advanced features like distributed AGs, which is a capability introduced in SQL Server 2016. Distributed AGs allow for cross-cluster replication, enhancing disaster recovery and hybrid cloud scenarios by enabling synchronization across multiple AGs. Now let's take a look at the process of enabling failover clustering feature here in Windows Server, which is essential for setting up not only the Windows Server failover cluster, but also AGs that we'll see in a little bit. Before a Windows Server failover cluster can be configured, the feature must be activated on every participating node, either through Server Manager or by using the PowerShell command install-Windows feature and including the failover-clustering include management tool switch. WSFC is a foundational component for high availability in SQL Server deployments, supporting configurations like, as I mentioned before, availability groups and the failover cluster. So it's an essential first step. Let's look at the critical process of validating our Windows Server failover cluster before deployment. Validation ensures that all nodes and configurations are suitable for clustering by running a series of built-in tests via Failover Cluster Manager, or you can use the test-cluster PowerShell command. The Results categorize each test as pass, warning, error, or not applicable, with all errors requiring resolution, while warnings may be acceptable depending on the environment. For Windows Server, this validation is essential to confirm that high availability configurations like always-on availability groups or failover cluster instances are correctly implemented and supported. Now, here's the process of setting up and validating an availability group in SQL Server, particularly within an Azure environment. While the AG creation process mirrors on-premise setups, a key difference lies in the configuration of the listener, which can be done using the SSMS, T-SQL, or PowerShell. A critical step is setting up an Azure internal load balancer, either basic or standard, to route traffic to the correct SQL Server instance. Standard is required for availability zones. The listener's IP and port must be configured in the load balancer, and a probe port must be added to the IP address resource in the WSFC, which requires a restart. Without this configuration, applications and users cannot connect to the AG unless directly connected to the primary replica. SQL Server's use of listeners and load balancers ensures seamless client redirection and high availability. This slide highlights critical configuration considerations for deploying always-on availability groups in Azure, emphasizing the need for a unique listener name and an IP address per subnet, since Azure does not support IP reservation for listeners. To ensure high availability and disaster recovery, it's recommended to deploy SQL Server virtual machines across multiple subnets, avoiding reliance on the Azure Load Balancer or distributed network name for routing AG. AG requires an underlying Windows Server failover cluster similar to on-prem setups, and all the participating VMs should maintain consistent storage configuration to support performance and reliability. For implementation guidance, Microsoft provides a ton of tutorials and walkthroughs where it helps you set up the listener setup, the IP conflict avoidance, and storage planning. So some of those are listed here on the slide. This slide outlines the essential steps for enabling the always-on availability group feature in SQL Server, which must be completed before configuring AG for high availability and disaster recovery. The feature can be activated via SQL Server Configuration Manager or, of course, through PowerShell using enable-SQL always-on commandlet. And it requires a restart of your SQL Server instance after the Windows Server failover cluster is set up. This setup ensures that SQL Server can support AGs, which allows databases to remain accessible during server failovers and enable readable secondary replicas for reporting and maintenance. Following best practices by enabling the AG feature early ensures a smooth and reliable configuration process. Setting up a distributed AG in SQL Server follows the same process both on-prem and in Azure, with the added complexity of creating multiple Windows Server failover clusters, availability groups, and listeners. Each WSFC AG pair requires its own internal load balancer, and in Azure, the configuration must include the AG endpoint port, typically port 5022, as part of the load balancer setup in each region. This architecture supports high availability and disaster recovery across geographically dispersed environments. SQL Server distributed AGs are a powerful enterprise edition feature that enables seamless data replication and failover across clusters, making them ideal for hybrid and cloud-first strategies. Here we see two key high availability and disaster recovery options for Azure SQL Database in a PaaS environment. We have active geo-replication and failover groups. Active geo-replication enables secondary databases across different geographical regions, allowing quick manual failover and enhanced data availability. However, since it operates per database, applications require a stable connection endpoint or group-level failover should use failover groups, which manage replication and automatic failover for multiple databases on a logical server to another region. This setup ensures minimal downtime and supports business continuity. SQL Server benefits include high performance for complex queries, secure and scalable data management, and support, of course, for ACID-compliant transactions. Use cases span from real-time analytics and business intelligence to transactional systems and global applications requiring resilience and low latency across its data. Best practices recommendations here are to configure automatic failover in failover groups and deploy geo-replicated secondaries to meet the RPO and RTO targets that you may have. Active geo-replication describes a great feature of Azure SQL Database that enhances availability by creating a readable secondary replica in another Azure region, which is asynchronously updated from the primary. This setup allows for manual programmatic failover in the event of a regional disaster, ensuring business continuity. Both the primary and secondary database must be configured with the same service tier and compute size, and cross-subscription replication is supported, offering us a lot of flexibility to manage the resource. Under the hood, Azure uses availability groups to deliver this functionality, which is why the terminology like primary and secondary replicas mirrors that of our SQL Server AG. SQL benefits include improved disaster recovery, reduced downtime, and the ability to offload read workloads to a secondary replica. Use cases here include global applications that require high availability, geographical redundancy, and seamless failover capabilities across regions. Here we see how Azure SQL Database supports high availability and disaster recovery through active geo-replication. It shows a primary and secondary region, each with its own logical server and load balancer, managed by Azure Traffic Manager. Under normal conditions, user traffic is routed to the primary region, which handles both the read, write, and read-only workloads. Database changes are continuously replicated out to the secondary. In the event of failure, traffic is redirected to the secondary region, ensuring continuity. For applications requiring a stable connection endpoint and automatic geo failover, auto failover groups are recommended. These groups automatically promote a secondary to primary if the original primary fails and relink all other secondaries to the new primary. Geo-replication and failover can be managed via the Azure portal, PowerShell, T-SQL, or a REST API. These capabilities are enhanced by Azure's geo-replication and auto-failover features, which ensure resilience and seamless user experiences across global deployments. Here we see the manual failover process in active geo-replication for the AdventureWorks LT database, comparing the primary online replica in South Central US and the readable geo-replica in East US. A red arrow points to the ellipsis menu on the geo-replica row, showing options like pin to dashboard, stop replication, forced failover, and more. After creating a secondary replica, users can manually initiate a failover to switch roles between the primary and secondary replicas. It's Key use case includes business continuity during regional outages, load balancing for read-intensive applications, and geo-distributed apps requiring local data access. Benefits include minimal downtime during failover, improved data accessibility, and enhanced resilience against regional failures. Best practices involve regularly testing the failover procedures, monitoring replication lag, and ensuring consistent configuration across replicas, and also using readable secondaries for reporting or analytics to optimize performance costs. Auto failover groups enhance high availability and disaster recovery for Azure SQL databases and for Azure SQL managed instances by automatically replicating databases to a secondary region and enabling seamless failover. These groups support seeding, which creates replicas of one or more databases on a secondary server, with the duration depending on the database size. They also provide AG-like functionality through two types of listeners, one for read-write and one for read-only traffic, allowing applications to connect without needing to know the failover details. DNS updates during failover ensure continuity. For SQL managed instance, only one auto failover group is supported, and the group name must be unique within the database.windows.net domain. This feature is ideal for mission-critical workloads that require continuous availability and minimal data loss. Best practices include here configuring the grace period with data loss hours setting based on your RPO needs, monitoring replication health, and then testing failover scenarios regularly, and ensuring consistent service tiers and strong network connectivity between regions. Auto failover groups enable seamless high availability and disaster recovery across Azure regions. Here we see geo-redundant architecture where a primary server is connected to a secondary server in a different region, with DNS-based redirection ensuring minimal disruption during failover. Auto failover groups support both read-write and read-only listeners and automatically promote a secondary to primary if the failure occurs. These groups can include all databases, like what we've required here for a SQL Server managed instance, or you can select individual databases if you're working with the Azure SQL database, but it must be configured on the primary server. Best practices include ensuring authentication and network access are properly configured on the secondary server to support a smooth transition, and selecting the appropriate failover policy. You can choose automatic for seamless failover or read-only to manage performance post-failover. Auto failover groups ensure continuous availability and minimal downtime, which are essential for mission-critical apps in a modern cloud environment. Auto failover groups ensure high availability and disaster recovery by replicating all user databases from a primary instance to a secondary instance in a different Azure region. System databases like master and MSDB are excluded from replication. The configuration requires both instances to reside within the same DNS zone, and performance is optimized when using paired regions. This diagram shows components such as our Azure Traffic Manager, ingress load balancers, DNS zones, geo-replication paths, and read-write, read-only listeners that manage DB traffic across VNets and applications. A key configuration detail is that the auto failover group must be set up on the primary instance, which then connects to the secondary instance to replicate user databases. Benefits include minimal downtime during failovers, improved resilience, and seamless continuity for mission-critical apps. Use cases here can span many industries needing uninterrupted access to the data. Best practices include deploying in paired regions for better performance, monitoring that seeding duration based on the number of databases, and validating that the DNS zone is in alignment here to ensure proper failover behavior. To set up an auto failover group in the Azure portal, you need to navigate to the failover group section under Settings and select Add Group. Auto failover groups are configured on the primary instance and replicate all user databases to a secondary instance in another Azure region. While system databases like master and MSDB are excluded, this setup ensures high availability and disaster recovery by enabling seamless failover with minimal downtime. Step 2 is to set up auto failover groups for Azure SQL managed instance, and we're wanting to ensure high availability and disaster recovery across regions. The auto failover group must be configured on the primary instance, which connects to a secondary instance in a different Azure region. All user databases are replicated to the secondary, while system databases, as we mentioned before, master and MSDB are excluded. Notice that to configure the failover group, you will need a failover group name, a secondary server, a read-write failover policy, and a read-write grace period set via that Azure portal. Once this is created, geo-replication begins automatically. Auto failover groups support two policies: automatic, which enables seamless failover, and read-only, which manages read-only traffic post-failover to maintain performance. Now let's see a comparison of auto failover groups and the geo-replication in Azure SQL environments. This is highlighting their respective strengths and limitations. Auto failover groups offer automatic failover, simultaneous failover of multiple databases, and support for SQL managed instances without requiring connection string updates, making them ideal for mission-critical apps that demand high availability and minimal downtime. In contrast, geo-replication supports multiple replicas and can operate within the same region as the primary, providing flexibility and regional redundancy for read-heavy workloads. Use auto failover groups for applications needing seamless recovery and continuous service, while geo-replication suits distributed systems requiring efficient read access across regions. Best practices here include deploying auto failover groups in critical systems, using geo-replication to balance the read traffic, along with regularly testing failover scenarios and monitoring performance to optimize resource allocation. Now it's time for our knowledge check. Question 1. What component in Azure needs to be configured for the listener in an AG to work properly? Answer: a load balancer. Question 2. What feature creates a replica of the database in another region that is asynchronously kept up to date? Answer: active geo-replication. Question 3. What setting for auto failover groups must be changed to ensure low RPO? Answer: grace period with data loss hours. Now let's see how to configure geo-replication for Azure SQL Database. And in this lab, we're going to go into and enable geo-replication in Azure. So I'm going into Azure, and in particular into Azure SQL here, as we've used this throughout all of our labs so far. And in this here, I'm going to pick up our AdventureWorks LT Lab 2. Here's the server, and I'm going to pick up that one right here. And we can make replicas of this database. So this database is riding on the database server DP-300 LPT2, and we're going to make a replica of it. And this is a way that you can make certain you have more than one of your critical databases available at all times. You can make a replica of it, where one is online and the other one is readable. Actually, you can make more than one replica if you'd like. So what I'm going to do is I'm going to click on Create Replica here. And when I click on Create Replica, notice that a lot of information is already filled in, and we really can't make changes to it. So what I'm going to do is I'm going to go down and use DP-300 Labs there. And as I scroll down a little bit, there you can see the database name is set. But you can make another server. So the server right now is actually West US 2. And let's verify that. So the server for that database that we're writing on now is Lab 2. We should actually be on one right there, which is West US 2. And now what we want to do is we want to move this new server. And when I pick a new server, it's going to ask for a name. And they have a number of names that they recommend here for us to use. Oh, just something here. Okay, so I'm going to do is I'm going to call this, let's see, this will be our AdventureWorks server, though rather the database. So let me do something very, very similar to the first one. It was DB-300 dash lab 2, and then we're going to put on it somewhere. We're going to put it somewhere now. And right now in West US 2, so the best place to put this is where? Well, the list of our Azure regions. We want to look for our paired region and pair the regions together. So, and it'll guarantee that one of these regions is always up in the pair. So we want to use our pair. Here's the URL for it up top. And then what I'm going to do is I'm going to go a little further, and I'm going to look for East US actually. West US 2 is right here, and it's paired with West Central US. So that's the one that we're going to use. So as I go down the list, I'm going to put this instead of in East US, I'm going to put it in West Central US. That is the pair for West US 2, and there it is right there. So I'll pick that up, and the name of the server, I'm going to include West Central US in its name. And the name, so there we go. So we can see where it's at by looking at the name. So I have one in West US, and then the other replica will be in West Central US. So very nice pair there. And then I'm going to scroll down, and I'm going to use Microsoft Enter ID authentication to get this set up. So I'm going to go find one out there, one of our SQL admins. And I will use SQL admin to do this. And I'm going to go ahead and select it, and there we can set that in as the SQL admin. And hang on a moment, there's another step, SQL admin. Make certain I have that selected. Okay, so that looks good. That should hopefully pull SQL admin in. Okay, I think we may resolve that number in just a little bit there. So I'm going to go ahead and click OK, and then this will have, let's see, then I'm going to go scroll down, and I'm going to see more there we need to do, and I'm not going to make it an elastic pool and the storage on it. I have the other one, basic, so basic should work. And I'm going to match so the two should match with the original server. The original was basic. This replica should also be basic. If it was something higher, I definitely would want to choose that too, but it's basic, so I should be good. Then I could also enlist a key here. If we have keys created, I can configure one here to use for data encryption. It's not a bad idea. And then for redundancy, since it's a replica, I could make this globally redundant also if I want to. But I have the backup globally redundant. And then I have this replica, and within the paired regions. So that could work here, but I'm just going to leave it the way it is right here. And there's, let's see, I don't have to set up networking or firewall rules at this point. And I'm just going to hit review and create now. And it's going to give me the essential costs to do this. And I can see them there, a little bit of a list of options. And there's a template that I can download, the JSON template. Again, if I'd like it to be in a different location, I can do that. I'm simply going to hit create once to do that. And it's going to take a little bit to run. And I'm going to see how it runs here. It's going to hopefully run a little faster. And it does take a bit to run. So we could come here and we can watch it through here, but we'll wait just a moment and give it a little bit of time to process. It could take up to 4 to 5 minutes or less to deploy this. It could be fairly fast, but it could take a little bit. So I'm going to let this cook in the background, and I have another one that we'll take a look at. So the other one that I've actually set up here in Azure SQL, I set it up right here. It's this lab right here. And when I get into it, what we will see is I can go to the replicas, and you can see the replicas right here. So once I go through the whole process of deploying this, you should eventually be able to get back into what you can see right here with the 2 servers. And you can see one has East US, and the other one is one is West US 2, the other one is West Central US. And one is readable and one is online. And I could add additional replicas if I like to do that. So I have one online, one is readable, and note that you can make Central US here, the West Central US, a failover. So maybe online has gone down, and it's a hard part here, but what I can do is I can do geo-replication to it. So online has gone down. I want to fail over. I can fail over to West Central US. And notice it's done manually. So with West US 2 down, I can do a failover. And it tells me a little bit about it here. It tells me, are you sure you want to do this? And I'm going to go ahead and say yes to that. And it's going to actually run fairly fast. I'm going to hit refresh a couple times. And you will see West US will become readable and West US Central will become online. It'll just take it a moment. It says failover is pending. And eventually West US 2 will be our option that will be readable, and West Central will be our online option. So it will just take it a moment here, and it requires manual failover, so that's something to consider. And we'll give it just another moment here. This may take a little moment here. Let it fail. It runs fairly fast. It just takes it a bit. You can switch it from readable to online and back and forth. So after it does roll over, we can roll it back if we'd like. Okay, so West US 2 is now readable and West Central US is now online. We failed it over. Notice you can force a failover, and that's another option. You can see what it entails there. So right now I can't wait for all the data to be refreshed there. And maybe I want it to fail over or force a failover. I can do that. I can also stop replication between the two of them if I need to do that and remove the replicas. That's another option. And I can add more replicas if I like to do that. So it's very versatile, but it is manual. So if the original goes down, I can fail over to the partner. Once the original comes back up, I can fail back to the original. Thank you so much for viewing this session. Hope to see you in the next.